And we're live. Wonderful. Hello, folks. Hi, John. Hi, Asaf. I'm incredibly happy to kick off another webinar in this series of webinars that we've been doing at Perfect Scale by Do It, where we invite some incredible folks, the thought leaders of our industry, to talk about all the things DevOps, cloud, Kubernetes, and now, of course, AI too. And I'm very happy to have John Willis with us. So, John, if for some reason you haven't heard about John, John is a DevOps legend, one of the founding fathers of the DevOps movement, also a prolific author, responsible for a number of very important books, such as DevOps Handbook, and also Deming's. What was the name of the book, John?
It's called Deming's Journey to Profound Knowledge, let's lay low on the prolific. I'm just good.
Okay. Yeah. Anyway, I'm very excited to have you with us. And John has just finished a new book on the history of modern AI, telling us all of the exciting stories that led to the moment that we're at right now. And we're all aware that there is certainly a tectonic shift happening in the industry. And John will share his insights on how this is impacting the industry as a whole, DevOps, infrastructure, and software development lifecycle in general. And we're also very happy to have Asaf with us. So Asaf is a co-founder and CTO at Logs.io. And Asaf, you'll share with us your view on how AI is impacting observability as we know it. And we'll have a discussion afterwards. Feel free to send us your questions in the Q&A section. More than feel free. We do ask you to send us questions because this is supposed to be a discussion. There are lots of unanswered questions as yet, and yeah, let's try to answer them together. And we'll start with you, John. So the mic is all yours.
Let me go ahead. Thank you. That sounds great. And you've been a pretty much a big part of the DevOps story as well. I think if people have been following along. All right, there's my slide. Hopefully everybody can see it. Yeah, just to give you a little background, this idea of shadow AI and technical debt. I think I have first use on shadow AI, but who cares? But I've always considered myself an infrastructure and operations person. As Tom said, I was one of the founders of the DevOps movement. But I've been in operations pretty much, I dabble in development in certain parts of my life. I've built software companies. I'll go over a little bit of that. But like at each sort of turn of a transitional or sort of transformational technology, I think a lot about like what is my responsibility and what are the people that sort of align with, sort of we'll just call it DevOps or DevSecOps or we might call it SRE. What's our responsibility? Our responsibility is to protect the brand. At the end of the day, we are protectors. And so at the beginning of each sort of, last big one was the sort of shadow IT, which was mostly driven by cloud. And as I started digging deep into the models at sort of at the GPT-3 level, late 2019, 2020, I realized this was going to be a couple of orders of magnitude more complex. And anything we thought technical debt looked like in the past is going to be, you know, child's play. So I've been really thinking about this. So let me go through the sort of the deck as we um, so a little bit just about me. I don't spend a whole lot of time. I'm easy to find. That's my LinkedIn. I'm sure the slides will be available at some point. I've done a lot of I've done like 12 startups, some of them terrible, miserable failures, but fortunately I've had a couple of wins. I sold a company to Docky. Helped sell a company to Dell. Those were pretty good. I was on an executive team at Red Hat. Currently, I do some consulting for MongoDB and sort of area, particularly around their Atlas Vector Search, which is their sort of vector database, or what most people refer to as a RAG. Written a lot of books. Again, won't spend too much time. Anton talked about the DevOps handbook, but the one I spent a big portion of my last 10 years working on was this Deming journey. A very interesting story there. A couple other ones. A couple more things I want to focus on because this is where I'm getting all my ideas. I created a newsletter called AICIO.ai, and I think it's the thing that's important about this is where I'm really trying to express all the things I'm finding. It's sort of the moniker is Dear CIO. Dear CIO, watch out for this. Dear CIO, and I've done some presentations. So I'm really trying to capture everything I'm finding that might be of interest to a large organization about the potential dangers, the title of this presentation, the technical debt tsunami or um, and anyway, so there's the other thing too, that book, it's called Rebels of Reason. I think I skipped over that really quickly, but that should be orderable in by June 1st, if all things go as planned. If you subscribe to the newsletter, I'm going to be sending out a special edition to anybody who's a subscriber at like an at cost price. But the thing, it will have a special sort of like thank you to all my subscribers. So anyway, so that will come out probably about mid to late May. Anyway, so a couple things I want to talk about is I want to talk about where we're at right now before I get into the scary part, right? Which is, part of like understanding the history is giving me some insight. This is a chart I found from Source of Contextual AI, but so this is when benchmarks started, pretty much, according to this author. And as far as my research is concerned, I would agree. In 1998 was some milestones. The first neural network used for commercial purposes. Most people refer to it as the MNIST handwriting, sort of a 101 if you want to learn how to build sort of a neural network. But the other thing is Dragon systems, which became basically ultimately Siri. That's sort of when benchmarking started. So you watch this sort of like this growth over the years in sort of different type of benchmarks, language understanding, and speech recognition, common sense pops up. But we get into 2015 or 16, right? A lot of things change. Like in 2015, there's a little bit of history, is the attention is all you need. That was the definition of the T in GPT, right? A little bit of history lesson. We'll get into the Dear CIO, the Tsunami stuff in a minute. But I wanted to point out, like, we get to like 22, right? And we know what happened in 22. But like, look at the growth of these, and we start seeing surpassing, and it basically going vertical. But this what happened then is like literally from like last June, if you look at like just two benchmarks, this tells you where we're at. Like we're not stopping this freight train. Whatever metaphor you want. The ship has left the station. The train is, it's a bullet train. Um, the In June of 2024, if you looked at two um, sort of benchmarks, one reasoning and the other one coding, in June 24, reasoning was around 60% and coding was 70%. I mean, if you look at in January, reasoning models based on, probably one of the more effective benchmarks for reasoning is the GPQA, 77% on reasoning, and code is 98%. And that's pre-Claude 3.7. So I don't know if you play with 3.7. I did. So it, what amazes me is in 6 months, like if you go back to look what happened over like 75, 80 years, but then you go look at what happened since June, and then you look at what happened this year with the reasoning models, the deep research, the deep seek, and then of course the speed, the quality, and the price. In most cases, the prices, the mileage varies. And then one last thing I wanted to talk about where we're at right now is there's what they call the SWE bench, which is software engineering bench. This is how well these are sort of solutions that are based on frontier models that basically can look at an issue in GitHub and how well they solve it. So last year, literally less than a year, or almost about a year ago, a solution came out called Devin, and it was solving problems at 13% in benchmark. Today, we are literally sitting in the mid 60% of literally how effective a model with a solution can close accurately, close or make a fix to a GitHub issue. Mileage varies on all this stuff, but and benchmarks are benchmarks, but like that's a pretty significant increase. So now's the part where I wanted to talk about like the scary stuff, right? This Dear CIO, my newsletter, my concerns about I'm not professing that like we need to stop or stop it, like we're not stopping this stuff, right? Just like cloud, we didn't, there was no stop. Anybody tried to stop the cloud really found that it was, sort of meaningless or fruitless. So basically, I do believe that people who are not preparing for this sort of shadow AI or this, the people are like people are just creating notebooks, people are creating chatbots, non-coders are becoming coders. I mean, there's just so many tentacles of potential dangers here that they're almost hard to keep up with. And so, so I wrote an article literally almost 2 years ago, this rise of shadow AI. And at the time, I just sort of, this could get really scary. And then a bunch of us wrote a paper last year called Autonomous AI in the Enterprise, and this is part of IT Revolutions. We can put a link to how to download this. But a bunch of us wanted, the thing we saw was CEOs were hiring chief AI officers, and chief AI officers were coming from like CMU and Stanford, and they were hiring a lot of students. There's this sort of mantra among CEOs now is only hire kids out of college. I mean, these are for like enterprise level bank, retail. I mean, like, so what you're seeing is these AI development groups that are literally just a bunch of people who have never worked in a bank. That should scare the heck out of you. You probably heard of the Air Canada problem, right? Like the Air Canada, don't be in Air Canada. This is where they wanted to build a chat bot. They scraped everything, including FAQs. A passenger wanted to see if he could get a refund for his mother's funeral. The chatbot said he would. When he went to go collect, they told him that was the chatbot, not the way Air Canada worked. It turned into a 2-year lawsuit. The brand reputation of Air Canada just was tarnished at the worst possible time to have a bot that's giving the wrong answer. A couple more points as we sort of go through this. When I wrote that article about shadow AI, I made okay, yeah, I'm probably not part of that, but the I made this prediction that if we looked at shadow IT, right, mainly driven by cloud, most organizations, like if you had a 100,000 person employee bank, maybe you had three, maybe if I'm being generous, 5,000 people who were involved in sort of cloud, because early cloud, you needed to do an API, right? It was a small group. And look how expensive that had been to recoup the sort of the technical debt with cloud. So my prediction was early on with seeing things like these bots, chat bots, people will be able to create chat bots pretty easily. With Copilot being able to help people write code, maybe not great code, maybe okay code, doesn't matter. I felt like that 100,000 person organization might have, instead of like 3 to 5%, 75% of people might be involved in this shadow AI. And then, unfortunately, last year, LinkedIn, Microsoft did a report where they literally, sort of validated my some of my concerns. That 75% of workers around the world use generative AI, 78% bring BYOAI, bring their own AI, right? So that's there's a couple other things if you've been following. I mean, Wiz, everybody's heard of Wiz now, right? Because they just got bought by Google, but they were been last year they were doing some incredible white hat hacking, and this one is one of the scariest ones that I found, which is, and they've got a bunch of great examples out there, but they put out a jailbreak embedding model on Hugging Face. So it had capabilities of escaping when you were doing inference against this embedding model. It had the capability of escaping out. So they actually put it on Hugging Face. It was a controlled environment. They ran it. It broke out. It was able to then break out of a Kubernetes cluster that Hugging Face was running under the infrastructure to run these embedding models. And then they were able to break out of that and they actually found themselves on a shared customer Amazon host. Should scare the heck out of you. So pay attention to jailbreaks. I've been writing articles about it. It's probably one of the scariest things about AI that like you need to, if you're concerned in protecting the brand, you should be concerned about this. Google wrote a paper in 2015. What's interesting is they were warning us of the problems we were going to see. They were doing it for themselves, but the hidden technical debt and machine learning system, almost all of this is relevant today for large modern banks, retail. The other one thing I wanted to point out real quickly as I wind up is that this idea that you run it, you own it. If you look at modern stacks that are built today on AI, they're probably 80% just infrastructure. They have all the components that we're used to. They have the library dependencies. They have, so the thing is, literally the 10, 15, maybe 20% is really the AI specific stuff. So to think that like some team of AI is going to manage and have the experience of hardening Kubernetes, like the Hugging Face example, it's not happening. Um, Keeping up on what's going on. I mean, the gatekeepers are doing a better job. I think MITRE is doing a fantastic job. OWASP is doing a good job. NIST is sort of catching up. So again, a lot of the experts that have helped us in security are sort of behind the curve, right? And there's tons of really scary phishing schemes in models, like a hallucination on a library in code. Literally, the adversaries are finding those, and then so when you run the code, it doesn't say missing package or missing library. It actually runs and pwns you. Uh, Stay up with OWASP, the top 10 LLMs. It's a treasure trove of information. There's actually they did two last year, and actually did one this year already. So this is last year's latest one. They're also integrating really well with MITRE and creating MITRE attack structures. And yeah, and so that's me. There's a kind of how to find me. If you have any questions, certainly we'll answer questions here at the end of this presentation. But yeah, that's pretty much the shortest version I can give of an hour presentation. Thank you.
Even in the short version, it was scary enough, John.
That's right. I hope I did scare you. Yeah.
Okay, Asaf. So
Yes.
now over to you, and do let us know how AI is changing observability as we know it.
Yes. So I also have a presentation. I think it's less scary. It does start with a scare, but so let me just share my screen here. And, okay, so I'll start by saying that one of the things that we're seeing, obviously Logz.io is an observability solution. One of the things that we're seeing, and I think a lot is kind of like following what John was saying, is that the application stability continues to deteriorate. There are more people writing more code now with GenAI and the ability to generate code that even increase it in an exponential way. The level of expertise doesn't go any higher. Cloud architecture and cloud component, Docker, Kubernetes, serverless, they keep on getting more and more complex. You keep getting the benefits of flexibility in the cost of complexity. Frequency of incident goes up, and the time to recover goes up. So this is a result. We're seeing it year over year. We've been doing it for more than 10 years now, started with a logging company, and now we're an observability solution. We're seeing it year over year. Every time we survey our customers, we survey people, we see that the number of incidents goes up, the time to recover goes up, and everybody's starting to have kind of like an issue with it. I'm just 1 second, Logz.io observability solution all over the world. We have customers all over the world. We are really transforming observability through the use of AI. So I think the use of AI to generate code, it's happening. We can't stop it. It does create a lot of issues. The use of AI to actually troubleshoot what's going on in a non-invasive way has a very high potential the way we see it. So Alan Turing wrote, and I think he was the probably the first one that I know. It was almost 100 years ago that he was talking about intelligent computer. He didn't call it AI then. It was just intelligent. And he said that the computer would deserve to be called intelligent if it could deceive a human into thinking it was human. I think we're pretty much there. So with ChatGPT, with the level of innovation being done on it, the speed of development, we are pretty much there. I'm actually surprised at some of the question that I'm asking it in, like, not in the even not in the workspace on a personal level. It's the level of accuracy and kind of like resembling a human with the errors that the human would make is really astonishing, and this is why it doesn't even always fit in all the places. The estimate is that by 2026, the AI would be smarter than any human being, and by 2030, the GenAI would be smarter than all the human being combined. So we all know the level of innovation that's being put into GenAI. We all see how much compute power, GPUs are being acquired. We all see the progression, like John showed in the past 75 years, almost nothing happened. In the past 6 months, everything is like there are so many models, the level of accuracy goes up. I think that we're going to continue to see kind of like advances in this space. So this is what we see. And kind of like the last slide that I want to say and how we view kind of like observability. We call it autonomous observability, and our path to do it, that our vision is that in some time from now, and I can't tell if it's going to be 6 months, 2 years, or 5 years, it's probably somewhere between the 6 months and 2 years. The observability solution that exists today are not going to exist anymore. We're going to have a different type of observability. Today, we are all relying on dashboards, visualizations, alerts, and all that stuff that we really cannot get a handle on them. There's too many of them. It doesn't help us solve the problem. The way we view it, we're going to see 4 different layers of different AI agent. There's going to be the user interaction agent, which is going to help people interact with all the data. So today, if I want to search something, I can write it in the search format of that specific observability solution. If I'm using OpenSearch or Elasticsearch, I have to write it in Lucene. It's very limited language. So the user interaction agent. Today, if I want to build a visualization in any observability solution, it's pretty hard. If you guys try to build a visualization in Logs.io, try to build it in Grafana, especially around the open sources, the level of complexity really increases. These are all things that the UI would do, GenAI would do. We're going to have exploration AI agents. That's the one on the top. So we're going to have agents that's going to run through the system and continuously check what's going on. What's changed in the system, what version were upgraded, what servers went up and down, what cluster happened, what is the connectivity with the outside world, which cloud is experiencing issues. All these things are going to continuously monitor what's going on with this, explore kind of like, and really map how the environment looks like, build a map of everything. There's going to be the monitoring agent, which are going to be replacing the alerts. They're just going to go around and figure out what is going to happen and what is going to impact the system without me having to define any alert. I don't need to set up the threshold. The threshold would be derived from these things. And kind of like at the end of the day, we're going to also have the remediation AI agent. So imagine this, I write code, or I use GenAI to write code, I push it in production. It goes through the CI/CD system, it goes into production. We have exploration agent that's going to say, hey, something has happened, change in the environment. Let's check what changed. What is changing in the availability? What is changing in the performance? What is checking on the security? What is changing in the cost? All of this is going to be changing based on the level of change, and the impact of it is going to activate the monitoring agent. It's going to say, hey, I need to alert someone because Asaf pushed the code into production, which created a security risk and increased our cost of operating by 1%. If this is too bad and I need to wake up someone, I need to make sure I monitor this. And then we can go into the remediation agent and say, oh, now I can connect to my source repository, whether it's GitHub or GitLab. I see the change it made. I can apply a fix to it. I can issue a pull request so someone can check it. I can write all the tests that it wouldn't happen again. And all of these things would be done automatically. So eliminating a lot of the things that engineers today don't like to do, and also DevOps professional of like looking at dashboard, looking at graphs, figure out what's going on, monitoring the environment, figure out if the alert was defined properly or not, and allow to kind of like fix it. So the whole thing, the way we see it, and I think one of the pushes that we're having in observability over the past 4 or 5 years is trying to move organizations from alerting on technology event or issues that happen to being only alerting on SLO and SLA breach. We're saying that the system is fine, it's recoverable, you design the system to be able to recover. We need to make sure that from a performance perspective, the engineering team is supporting the business in the best way and is committed to delivering within the service level objectives of this specific function and capability. So this is kind of like how we see the journey towards autonomous observability. I think I always give the analogy of autonomous cars. We've been promised probably more than 10 years ago that we're going to have autonomous cars. It doesn't happen yet. So even though there are some cars that are autonomous, they wouldn't drive on their own for unless it's like for a testing period. They would have a driver. They would like if you change your view from the front, then they would alert you. But throughout the development of autonomous cars, a lot of the technology leaked into the regular cars, like the auto lane correction or the advanced cruise control or the self-parking. All of these things came from the development of AI within self-driving cars. I also think that the biggest problem of the self-driving cars is the non-self-driving cars, all the manual cars, the people that are walking in the street and stuff like that. Today, engineering environments, cloud environment are already automated. There is no single person who's going to say, hey, I'm going to set up a server, I'm going to install a software, and then I'm going to run it and see what happens. It's all being automated. So we're already working in an automated domain. I think the level, it's going to be much quicker than having self-driving cars. And kind of like this is how we see the vision. And I think it's a good way of leveraging AI to address issues. It doesn't write the code. It doesn't create a lot of risk. It does help with a lot of mundane tasks of looking at a dashboard that's comprised of 100 different visualizations, trying to figure out what happened in the environment, especially in a state of connectivity or a mass storm that a lot of the things break, and now you have to understand really, really quickly what happened. So this was about 10 minutes, kind of like about our vision, how we vision the use of GenAI to help with engineering, cloud architecture, DevOps, and I really think, like you mentioned, this is we're facing a tectonic plate a change here, and this is it's going to be a revolution of things that are happening. This is not going to be a minor feature into development. It's going to be a big thing with a lot of challenges, like any new thing that is happening, but also with a lot of benefits. And I think we're at the point where it's unstoppable at this point, and we have to commit to using it. And like I say, like I think, like John mentioned, do it in a very careful way and understand the impact of it and understand what's happening, and really leverage it in the right place and make sure that you make sure that it doesn't go into the other places as well. So this was me and us. Happy to hear your questions.
Yeah, folks. So yeah, definitely send us your questions. So up until now, we haven't had any questions yet. But yeah, John.
Oh, I was going to say, I think I had some really good. That was a great presentation, Asaf. I really enjoyed it.
Thank you.
If we don't have any questions from the audience, I'd like to pick Asaf's brain a little bit on some things that I thought were interesting in his presentation. But I'll let you moderate when and where. So.
Yeah. First of all, John, definitely go ahead. I think it's very interesting because, like, here you are, John, telling us this widespread use of AI brings all of those dangers and the tech debt, and then Asaf, you come along and you're saying we're gonna have those autonomous agents, these machines of love and grace watching all over us, and problem solved, right?
It's always a vision. The reality sometimes it's a little bit different, but we do see a lot of potential for it addressing a lot of issues. Yeah.
So yeah, so there's definitely room for discussion here. We got 2 questions, so yeah, folks, definitely send us more questions. This is good. We definitely want to know what you are thinking of. So first question is from Alex Hardy. What are some use cases you're seeing from Logs.io customers? So what you already see regarding the use of AI in observability?
Yeah, so I tell you 2 use cases that we're already seeing. One of them is automated root cause analysis. Just say now you got an exception, you got an error, you woke up at 2 a.m. in the morning. What is going on? And the AI actually does a very, very good job at it. To tell you that it's 100% accurate, it's not. I would say it's probably less than 50% accurate, but if you follow all the steps, it's very logical, and you also understand what it excluded along the way. So it start to check deployment, and it start to check different exception at the same time. And it's like everything that almost like I think there was companies that did what was called the AI ops. I don't know how it's called today, trying to correlate all these things, doing anomaly detection. It just does it on its own. It's trying to really solve a problem. The other thing which we're seeing is NOC automation. So if you think about it, the ability to ingest the entire run book of a company and saying, okay, now I got this error, go through the run book and figure out what is the right thing to do. This is something that the AI does a very good one. It doesn't actually automate the run book, but it does give you solutions from the run book. Hey, you should increase that number of nodes, you should increase that capacity, you should reduce this capacity, you should limit the CPU, all these things you can do. So these are 2 kind of like 2 kind of like main use cases that we're seeing.
Okay, there are more questions here. Okay, but John, I would really love to hear what you had in mind when you said you wanted to ask some questions regarding Asaf's presentation.
Yeah, no, I think, and it fits very well with one of the questions. So there's a question about when you're talking about using GenAI and monitoring, but there are a lot of other ML types. So I think I wrote an article last year called Postmodern Observability, and I think a lot of people, as we sort of evolve into sort of pre-AI, sort of like before like the explosion, like observability was pretty clear, right? It was like sort of log-Z approach and some of the other vendors that are well known for really describing this new paradigm of observability. We could be cynical and say it's just it was monitoring, but I think observability definitely as defined by charity majors, at least in the IT spectrum or cloud native spectrum, I think has its foothold. Okay, but I think as I play with like these idea of these sort of ML tools that have now emerged under the umbrella of observability, I've been calling that sort of postmodern observability. So like modern observability, so like tools that actually do monitoring for correctness or bias or hallucinations. And I think, so this question plays really well. I think like when you asked about, is it just at Gen AI? I mean, a lot of the process that you do to create Gen AI uses a lot of the classic ML tools, like embeddings, like understanding how to fine tune an embedding, or even RAG itself is sort of a pre Gen AI. I mean, it's implemented because of Gen AI, but the thing I thought was interesting about your presentation is I didn't realize until you started talking about autonomous observability. Is like I thought like there's these 2 worlds. How do we atom smash them together? This modern and postmodern, and are we going to have this sort of like mistaken identity problem of what is observability? But I think I really like the idea of probably like sort of an agentic approach to monitoring, which will lend itself clearly to combining both worlds. I need to know token counts, I need to know latency, I need the performance of the services that are running, and I also need to have things like making sure I'm not doing blatant lies like the Air Canada thing. So I thought that helped me ground some of my thinking about like
Mhm.
where we're going, and where it's obviously like you guys are going to combine a sort of an agentic approach. And then the other part was the question was, I don't know why I thought this, but I didn't see remediation as part of this. And so could you dive a little deeper and I think you're right. I just like for some reason I wasn't thinking of like an agentic remediation as part of observability. That I think I was misguided.
Yeah, I think that it's definitely, this is not going to be the way we view it, not going to be entirely within, all of it within observability. So observability is going to be the center of it, but there is a very clear way of saying, I know what change was made. I know the code. I can see the code. I can fix it. And I can say, like you mentioned, like if entering a GitHub issue and solving that issue, I think
Right.
writing code is something that it does today now. I don't think it's going to be fully automatic. I mean, you issue a pull request, someone is going to go through the pull request and say, does it make sense or not? Sometimes, like, I want to do something that maybe there is another fix for it. I don't need to fix the code. I need to update the system in a way. But I think if we operate it in a way that's going to give you, okay, this is the layout of the problem. It started by you deploy the production, you guys start getting these exception, or CPU went up, or memory, or the cost change, and this is the impact. If you want to reduce it, this is the action that you should be doing. I think it's going to be very, very powerful, and getting to kind of like a remediation would be amazing. So this is kind of like how we view it, and we try to obviously draw a vision that is really exciting in a way. It's going to create change, and not only kind of like monitoring better, but also tying up all the ends between a change that was made into the environment and how we detect what happened and how do we fix what happened. So this is kind of like how we view it.
Brilliant. Thank you.
Yeah, I definitely agree that the remediation is basically, the missing part that we're all waiting for, because, up until now, there was an issue with observability, the generic observability as we know it. Like it was generating so much data that no human being could possibly, analyze it or find the issues with it. So we still needed to configure those, agents to find the bits that we're looking for. And then again, how do you do this? If you're only coming from your human understanding of the system. So yeah, if
I think
we
also
do
there is
complete this cycle with autonomous remediation, then it will definitely, finally, probably serve its original purpose of keeping
I
the
also
system
think that
stable.
it would also address and optimize the cost of observability. So I think this is one big thing that we're seeing companies suffering from today. Observability is too expensive. It's too expensive because the real-time databases to keep data, if a company is running 10 terabytes a day and you want to send it for, let's say, 14 days, which is not crazy to save the data, you're saving a lot of data. So a lot of data in these type of data stores is very expensive. Now, why do companies keep it for 14 days? Because they cannot get to all the problems in the same day that they happen. So, but imagine if you have something that's going to run through it just when it happens, change it, fix it, go into production, and then you can save the data in a S3 bucket, something which is like an order of magnitude, if not two orders of magnitude, cheaper than what you get in these databases. You can really save on of observability costs, which is a hindrance today for companies.
Well, and just to follow on that too, like I said, like so there's the modern and postmodern. Postmodern is really mostly around inference to sort of judge, like sometimes referred to as LM as a judge, the sort of inference to using sort of frontier models or certain inference model to see if it's hallucinating or how to correctness. And this is an ML science that's around forever. But what I'm finding some of my customers is the actual inference cost, the actual cost for evaluations is becoming higher than the actual inference cost for the application. So in other words, you have a co-pilot or a chatbot that answers questions in an organization, and to ensure that you don't get bias or toxic or blatant hallucinations, you use these evaluation tools to evaluate or judge, and turns out those costs are becoming higher than and then on the storage costs, auditors are requiring all ingress and egress of prompts to be saved for like a really long time. Like, so there are definitely a lot of costs to doing this right, but I don't think you have any other options.
Yeah. Yeah, I mean the options are is putting it in a lower cost storage as opposed to a real-time storage. From an audit perspective, it's usually sufficient. It's searchable, so it's sufficient. But we do see it as a challenge in observability. I think what we're seeing over the past few years is that companies are sending more and more data, and it takes them longer to troubleshoot. So it's kind of like counterintuitive. You're spending more money, but you're not getting what you want. And getting an observability solution to be more feature rich is not really helping people be more efficient at their work. And this is why we're here, to be efficient at what we do.
Yeah, those were exactly my thoughts when you started your presentation. So you're saying we see the time to resolution going up, and with thousands of millions of bucks thrown into observability in the last decade, we're not improving. So that's funny. And another thing that definitely jumps to mind is saying that AI is gonna make observability cheaper, is ignoring the fact that AI by itself is still very resource intensive and expensive to run. So what do you say about that?
Yeah, I think definitely the cost is obviously an issue, and we're trying to make it kind of like more efficient to do. At the end of the day, I think, like I said, the job of the engineering team is to serve the business, is to solve business problem and have the business agility. The whole cloud and Docker and Kubernetes and all the different technology are there to create agility in the business, because businesses that are not agile and not in the cloud, they cannot survive. The competition is too high. With agility comes complexity, and with complexity comes more difficulty to solving problems, and then the problems become they take longer to address, and there are more problems. This is kind of like a balance, like we've been focusing on the past, I would say 10 years of making sure that we increase to the level of extreme our ability to be flexible when we develop code. So I remember when I developed code, you had the server in a colo somewhere, you write the code, you push it. If you need to buy a new server, you have to wait 2 weeks and rack it, stack it, and it takes a long time. And now it's like that, and you put code into production that easily. And it gives businesses the edge that they needed when it comes to flexibility, but it does create the complexity that the people in the DevOps team are dealing with.
Yeah, and I think the other thing I'm finding, again, back to the inference problem, the cost of inference, like this, what we call just token cost, right? Which is organizations need to be really creative. One of the things I've seen is an organization will sort of plan to go all in on, sort of a cloud base, like an OpenAI. We're going to go all in OpenAI. Even, large corporations, that they're doing this, right? Like they assess the risks, they assess the costs, they create a relationship with OpenAI, so they get some type of contractual cost agreement. They can create gateways. They'll integrate Okta. I mean, they'll do all the things, right? But when they're planning that, they're accepting that there's going to be a reasonably high cost to all their inference, like all their chatbots and all those things. But what they're finding is, after doing this for like a year or so, they didn't realize they were going to have a double cost because of the evaluation stuff. So one is, that's a danger where people think through, I'm going to use public sources for, like, maybe Claude, Anthropic Claude for code generation. You still have to implement this stuff. So then what you have to do is, if you know this up front, you can architect these hybrid solutions where maybe you can do a fair amount of it, certainly almost all the evaluation inference during development in the pipeline as you're developing. In production, then you have to get really interesting about like maybe you offload the prompts, the answers, the questions, all those things. There's also guardrails, which is sort of generally associated with the evaluation process, but not exactly the same. So you have to run, and guardrails are in general inferences as well, and token costs. So like that's basically protecting that somebody didn't ask a terrible question in a prompt, or somebody didn't try to implement a jailbreak and just Google jailbreaks and you'll OpenAI, ChatGPT jailbreaks. Yeah, so the cost of all this stuff is something you have no choice, but you have to be creative about sort of on-prem, off-prem. How do you architect these things up front to deal with those sort of hidden costs that you'll get hit with down the road?
Yeah, I think
And
definitely cost is an issue. And first of all, I mean, you've seen and I think you've showed that the cost of AI is just going down, and the number of token being the ability to support the number of tokens just goes up and up all the time. The number of token is also an issue because you're dealing with quite a lot of data, not like 10 or 20,000 tokens like AI exists. So it does create some complexity of making it work. I think the cost is going to go down, but I think like everything in life, it's just going to transition somewhere else. So if people are going to be more efficient in writing code, you would need less people to fix the environments, and they're going to be cleaner and going to operating smoothly. From what we see, production issues are predominantly because someone changed something, and B, a problem existing in the environment that nobody noticed, and it wasn't manifesting enough to make an impact. These are like the two main reasons. It's not like 100%, but it's probably 80 to 90% of the problems is because someone changed something, or there is like something that was lurking in the environment and nobody paid attention to it. And these are things that are ideal for things to just run in the background, search for these things, troubleshoot them. It is going to cost money, but the money is going to be, instead of having a team of SREs with a very high level of expertise on how to solve very, very complex multi-cloud, multi-region, multi-AZ clustering environment it's really hard to address. So yeah, it's going to be expensive, but it's going to come at the expense of fewer people doing it, and they would be doing something else.
No, I think I mean, but then, again, there'll be the human in the middle. And then, the biggest question right now, you talked about the beginning, and I kind of alluded to the unknowns, right? We just don't know what the patterns are going to look like when we start building this at scale. So there are assumptions that reasonableness means we're going to need our architects. They're not going away, right? Architecting good sound infrastructure, that hopefully, fingers crossed, that doesn't go away. So there will always be sort of like expensive humans in the process, but in the end of the day, if you're a bank that had 20,000 Java developers, you don't have that now, and you won't nearly have that. If we could look at sort of black box trading or algor trading, that industry went from large banks having 10,000 day traders to now like 300, on the same principle that you just didn't need humans to do the sort of make like the computational advantages. So yeah, so there's so many unknowns on what our world is going to look like in 3 or 5 years ago when it comes to humans and cost. Because one other thing I will say is I tend to agree that cost is going down, except recently the reasoning models are getting more expensive, right?
Yeah.
And so where is that going to wind up? Because the cost of those reasoning models is just getting exponentially high for the providers, not from the amount it takes to train, and now the amount it takes from just the energy cost, utility cost to run those things, right? So again, there's just so many unknowns to this. The best we can do is try to behave like we've done in the past as good DevOps, DevSecOps, or SRE citizens and architects.
Absolutely.
yeah, definitely. Here is a question from Daryl. Well, it's less of a question, but it definitely points out an issue that we're all aware of. So it says like autonomous coding is clearly empowering non-engineers to push questionable products to production with minimal oversight. Do you see this leading to regulation? And then he says, Meanwhile, we're watching the average developer regress into an AI monkey role, churning out low-quality code, much like the web monkey days of the late 90s. Curious how others are seeing this unfold.
I'll take first crack at that. I think, the more we position ourselves as these tools are, I mean, my book, the last chapter of my book, in my epilogue, I talk about the philosophy of AI, which is pretty heady, but I talk about how we should think about these things like any other technology phase and not get overwhelmed that these are companion tools. There's a great article, video of Steve Jobs, and it's called Bicycle of the Mind. And it's a beautiful, when he was talking about how computers, like there was an article he was comparing about how the Condor is like the fastest earthly animal or whatever you want to call it, and then it ranked humans down pretty low, pretty mid low on the list. But then when you put a human on a bicycle, it was actually more efficient, and it wasn't just speed; it was efficiency. All these, the human on a bicycle was more efficient than the Condor. So again, I think the idea that that people are getting dumber, I don't think so. I mean, I'm better at research than I've ever been with tools now. I think people who design good architects and good guardrails are getting more efficient at massively developing code. And let's face it, if you had 20,000 developers in your organization, how many of them were really good coders? I mean, just take the bell curve, right? So this idea that humans were great at this stuff in the first place is sort of a false flag. So.
I think that the point is true, and I can tell myself not about coding, but I can give you an example. I wanted to do a project with one of my kids recently, an Arduino project to do like lighting and temperature sensors and humidity and stuff like that. And I have zero experience. I've never done this before. So I used ChatGPT and he gave me like the whole list of equipment I need to buy, the wiring that I need to do, the code for the Arduino. You just plug it and it just works. I didn't even read the code of what it is. And like and like I think this is a good example of things that are going to happen. And people that do have programming expertise start a little bit lower. It's not going to get dumber. They're going to be focusing on other things. Hopefully, they're going to be focused on architecting better. Hopefully, they're going to be focused on creating the right technology and choosing the right solution, but it's definitely going to happen. And I'll give you another example. So, unrelated to AI and coding, like when I was growing up, I remember all the phone numbers of all my friends, all of them, because we didn't have cell phones and I called them at home and I remember all of it. Like we didn't even have a memory in the phone. Today, I remember zero phone numbers. I don't remember these phone numbers. If something like if I lose my phone, like I don't know even who to call. And so I think we're going to know less and less about, and we're going to keep fewer details in our mind to be able to do it. And it is a change. The world is changing. We can't undo it, and it's going to have an impact. It's going to have an impact on the level of on the overall profession of what does it mean to be a developer. It's going to be different 10 years from now than it is today, and this is progress, and this is going to happen. So hopefully we would know other things, and we would know as developers to how to look at the code and understand it and how to do it. But the ability to start from scratch, saying like I have like zero and I'm going to write every single line of code. I don't think this is going to be the future for people. And slowly they're going to start forgetting the things that they don't use. Like I don't use remembering phone numbers, and I don't forget it. Like I don't use it anymore. So I think
Yeah,
yeah. Yeah.
in a way, you could say this is basically us going back to the way we're naturally wired to be, right? Because nobody's naturally wired to remember his friends by numbers, like, assigning a number to each friend and managing them like that.
Well, I mean, I think with this one the other day, it was just regular expression, right? Like, if you're not like a hard pipe hitting everyday sysadmin, every time I have to do a regular expression, I'm like, oh, okay, this is, okay, how do I get the four? Now it's just literally a 4-second question. I mean, and did we really need to have humans be, sort of, I mean, there are some, and no disrespect to if we know, everyone knows somebody who can literally just eyes closed, standing on their head, do incredible things with regular expression. Do we need that type of expertise? The question is
Yeah,
no.
it basically all goes back to language. We needed a language to talk to machines, and
Yeah.
now machines are finally learning to talk our language.
Yeah, exactly.
Okay, folks, we're done. Basically, this was an exciting conversation. We do have a lot of questions that we won't have time to answer right now, but I'll send the questions over to you, and maybe we'll come up with a follow-up panel for this, or maybe we'll do a blog post. Let's talk afterwards and see what we want to do with this. And thanks to everybody who joined. Thank you for your great questions. Definitely exciting and a bit scary times to live in. Let's see how all this unfolds.
Yeah, thanks for having us. And
Yeah,
thank you
thank
very
you.
much, John. It
Great.
was nice to connect.
Great being on this.
Thanks, Asaf. Thanks, John. Bye.
Bye-bye.
Bye-bye.
Have a good one.